Hello students, today we start a new chapter, Chapter 6, in which we will learn how species change over time. We'll begin with Section 2, which covers the concept of natural selection, and then we'll follow with Section 3, where we'll investigate the evidence that supports the theory of evolution. Okay, let's begin by recognizing that for most of human civilization, people knew very little about life during Earth's distant past. As a result, people naturally assumed that the forms of life that they saw around them, that is, the trees and the rabbits and the horses and the people, that all those forms of life had existed that way throughout all of Earth's history. In other words, the life forms that they could presently observe were the only life forms that there were, and that these existed and remained unchanged since the beginning of time on Earth. However, in the 1700s, progress in the field of paleontology resulted in significant improvements in the fossil record. Many paleontologists began to find fossils of strange organisms that had never before been seen and that were different from any presently living organism. With this new evidence, people began to understand that life on Earth was not fixed. In other words, it hadn't remained unchanged since the dawn of time. And as a result, people began to propose different theories of evolution to explain how life had changed. The term evolution is used to describe the change in the inherited characteristics of a species over time. So, for example, in this picture, the picture we see here below, we can see several different ancient species that are ancestors to our modern horse. If you look carefully at the leg bones in each, so here and there, and you have to look closely at it, but you can see that over time, in each of these species that are related to our modern horse, we see that the leg bones have changed in size and number of toes. Here you can see that in this species, the toes have been reduced to one hoof. Oops. I'm sorry about that. Whereas here at the very beginning, there are multiple toes. So the number of toes has changed, the length of the leg bone has changed, and of course we can see the size of the skull has changed over time. Okay, so from there, you can see the skull here is slightly elongated and much larger, and here again, much larger with an elongation in the front. So all of these changes inherited generation after generation over a long period of time result in evolution. And from our first ancient species here, we get something close to our modern horse. So, once people understood that species can change over time, the most natural question to ask is what causes species to change? Why do they change? Well, in an attempt to answer that question, in 1809, French biologist Jean-Baptiste Lamarck suggested the hypothesis of acquired characteristics. This hypothesis states that traits that develop during a parent organism's lifetime could be passed on to offspring. Let's look at a couple of examples, starting over here with these giraffes. Okay, so if we look at these giraffes, according to Lamarck's hypothesis, you might have a species like this giraffe that has a shorter neck, but some of those giraffes may be in an environment where a longer neck would be beneficial. So, for instance, here we see that the giraffe's food source is up high in the trees. And according to Lamarck, what would happen is that because this organism wants to get at its food source high in the trees, it's going to use its neck, that's why it says use there, it's going to use its neck, stretching its neck day after day, and that after many days and weeks of use, months of use, that this organism's neck would actually stretch out to become longer to better reach the top of the trees. And the second part, then, of Lamarck's hypothesis would state that once this organism has stretched its neck, its offspring, the babies that it has, will also inherit this longer neck. So this one here, this is the offspring. And Lamarck said that the reason that this offspring has a long neck is because the parent offspring was able to stretch its own neck in its lifetime, and this organism benefited. Oops. Oh, Lord. Sorry, guys. So this is the offspring. What you see in the previous picture is the parent. Okay, this, if you could, in that space below example where it says giraffe necks, I want you to summarize in your own words this example of the giraffes, because nothing's going to come up in that blank space, but you should have a summary here of what I just said. Let's take another look at a second example. So in this second example, let's say you have a woman and she works out a lot to try to increase the size of her muscles so that she's very strong. So what Lamarck would have said is if this woman works out every day and as a result she has developed larger muscles, then those larger muscles can be passed on to her offspring. So, what we know today is that Lamarck, although he was the first one to try to explain how evolution occurs, how species can change over time, Lamarck's hypothesis was actually rejected because several collections of data from several experiments did not support this idea. We could actually observe, if we wanted to, we could set up an experiment where we have women work out and try to grow their muscles, and then we can see if those characteristics get passed on to the children, and what we know today is that they don't. So Lamarck's hypothesis is incorrect. Okay, so this is incorrect. Actually, don't cross that out though, because you need to know the name of his hypothesis. But please know that this is not the way that species do change over time. So, what we're going to look at in our next lecture is the observations of Charles Darwin, who countered Lamarck's ideas and proposed the theory of evolution that, in fact, today's modern understanding of biology is built upon. Okay, we're done with this for tonight. Again, please make sure that you have described, and we'll talk about this in class tomorrow, but please make sure that in each of these blanks you have described what Lamarck would have suggested would have occurred in the case of giraffe necks and large muscles. All right, don't forget your Quizmodo, and I will see you tomorrow.